I'm going to be showing you a quadcopter drone that I've put together, and the airframe is the F450 DJI airframe, and I have a flight controller on board. It's a Pixhawk and a GPS module. I'm going to be exploring a flight mode called the position hold on this drone. So let's go to the field. Hello everyone, hello YouTube, and welcome to my channel, the BeatsTechLife. I'm Reuben Ambi, and today on the tech side, it's about drones. I've built a quadcopter drone that I would like to show you, and of course I've made a complete video series from the drone engineering to its flight and how to build one for yourself. And of course you know what to do: subscribe and hit the like button and the bell so you can get notifications when I do such videos for you. Now I'll be carrying out a type of flight mode called the position hold. Out of the many flight modes of drones that we've got, I've chosen the position hold to show you in this video. So come with me, and while we're at it, I'll be giving you update with regard to the attitude and altitude of this aircraft while in flight and its adherence to the position hold mode. Come with me. So the position hold mode is a GPS dependent flight mode. So the drone right now is picking up the GPS signal. I've gotten the signal, so I will take it up and fly it to a location that is suitable for my experiment. So what I want to do is to test the efficiency of my build with respect to the position hold mode. So what is this position hold mode? It is actually an autonomous flight mode that is mostly GPS dependent. It is similar to the loiter mode, where the aircraft just loiter around following a predefined path. But in this mode, the vehicle maintains a constant location, heading, and altitude in a three-dimensional plane. So what that means, when I fly the aircraft to a position, it gets locked. It locks itself automatically at that position. That any induced force is not enough to take it permanently out of its position. It can momentarily take it away from the position, but the aircraft automatically finds its way back, maintaining its attitude and altitude all by itself. So all you need to do is let go of the sticks of your radio controller and let the drone take control. Now notice the color coding on the frame of the drone. The red is forward and white is back. Now I'm pushing it backward, it's coming back. Sideways, it's coming back. Even along the vertical axis, upward, it's coming back to its original altitude. So you can hear my guys are amazed.
Same position, man.
Yeah, it's coming back to its same position. And I'm pushing it forward. It reverses, still maintaining the heading. Notice the red color, still facing the same direction. Okay, is that some kind of suspended simple pendulum we've got over there? So I've just turned off the position hold mode, and just for the fun of it, I'm making the drone to yaw. You can do that by moving the throttle stick left or right, depending on the direction of spin that you want. Now I'm about to fly the drone back to its landing area. So that was it on a position hold mode of a drone. And please note that this flight was made on a windy day, yet I like the resilience and stability of this drone. If you agree or disagree, please let me know that in the comment section below. If you have any question, please go ahead. Do not hesitate to ask, as I will also be posting videos of how this drone was made from start to finish. Please don't miss out. You know what to do. Hit the like button, subscribe, and hit the notification button so you get to see when I make such videos. Thank you, and see you next time.